Okay, so the much awaited and ballyhooed significant figures. Some of you have seen these before, and so you know that it's not that exciting. I actually never saw these till college, so if you're seeing them for the first time, you're just like me when I was in your situation. So we're going to talk about the rules and everything, but essentially it's just how to be an error accountant. That's what we're doing. And so I'm just going to go through like it's a rule book, because there's going to be rules. We're going to start out with the rules for just a number, and I'll actually make a second video where I talk about rules for a math operation like addition and subtraction, and then I'll make another one where I talk about multiplication and division. So I'm going to break this up into 3 videos. But there are 4 rules. And I always abbreviate significant figures as SF, by the way. So you're going to see SF for significant figures in a number. Okay? Rule number 1. All non-zero digits are always significant. So they always count. Alright, so what does that mean? Well, if we look at something like the number 12, and I'm gonna ask some very difficult questions here. It's unfortunate I don't have a class to answer them for me, so I'm basically just talking to myself about this. But, alright, let's look at the number 12. So there's 2 digits here. And I'm going to ask a very difficult question. Is 1 a 0? You know, if I'm walking into a building and someone says there's 0 bears in there, does that mean that there are no bears in there? Or does it mean there is 1 bear in there? Like, is 1 the same as 0? The answer is no. Is 2 the same as 0? Another tough question, and the answer is no. So guess what that means? Well, that means we have 2 significant figures in this number. That 1 is significant, that 2 is significant. So this is a number with 2 significant digits. That's what we're looking at. And now you're going to say, well, okay, there's 4 rules, and the first one knocked out everything that's not a 0. I'm not sure I like where this is going, and the answer is yeah. Yes, yeah, you got the right idea. There are 3 rules just about zeros. Alright? Rule number 2. Any zeros, or all zeros between significant digits are also significant. Alright. So what does that mean? Well, I like to call these sandwich zeros, by the way. You don't get that kind of quality education just anywhere. So these are what we call sandwich zeros in the business. And so let's say I have something like 1, 0, 0, 2. Okay. Well, from rule number 1, we know that that 1 and 2 are significant. That's not a 0. That's not a 0. They're going to count. Alright? And so these zeros are in the middle. Those are going to count as well, because they are sandwiched between 2 numbers that count. That's significant, significant, therefore in the middle is significant. So you have a continuity. You don't get to like counts, doesn't count, counts. Like it's going to count all in a row. And so that means we have 1, 2, 3, 4 significant digits in this number. Okay? So next, there's a couple situations zeros can be in. These are called sandwich zeros by me, and I don't know if anyone else does, but I really like the name. I'm going to make it take off. Literally dozens of students at a time are learning this. And eventually I'll reach hundreds of students, and then thousands, and then maybe they'll tell their friends, and then everyone will be on board with sandwich zeros. And then I can retire in peace, knowing my work is done. I've made the world a better place. Alright, so after sandwich zeros, we're going to talk about leading zeros. And I'll show what that is in a number in a second. But leading zeros are never, I cannot emphasize that enough, significant. Never. Don't trust them. They are never going to amount to anything. They're like, oh, I've turned my life around. I'm a better zero. I'm a significant digit. I've really learned my lesson. Next thing you know, your car is gone, your wallet's gone. They've stolen your social security number, and they know your mother's maiden name. So it's game over, checkmate, goodbye credit rating. That leading zero is going to run it into the ground because you can't trust them. They are never significant. You're going to wanna. Rule number 4 is going to make you think you can trust leading zeros. We'll talk about that in a little bit. So what am I talking about here? Well, maybe I have something like 0.01002. So I have to write these zeros in for placement of the decimal. I can't just not write them. Here's our sandwich zeros from before, a 1 and a 2. You might see a pattern in my examples here. I'm nothing if not someone who will train you to learn how to just read the patterns. I'm not going to reinvent the wheel every time. I got a 1 and a 2, and I'm just going to keep throwing zeros in it. Alright, so 1 counts, 2 counts from rule number 1. These zeros in the middle, rule number 2 says those sandwich zeros count. But what do we have here? We have digits to the left of our first significant value. So these are not significant. These are leading zeros. So if I'm going left to right, that's how we read in this country, in this culture, in English. You know, there's some that go up, down, there's some that go right, left. We go left, right. And so as we're reading, that zero doesn't count. There's nothing to the left of it to make it count. This zero doesn't count. There's nothing to the left of it to make it count. These are leading zeros. And I have to have them for placement of my decimal point. So it's not like I'm just throwing them in there for, you know, laughs. Like, there's a reason they're there. Then the 1, we're like, oh, that's our first significant digit. So a 0 can't be our first significant digit. And those are leading zeros. So the 1 counts, and then these zeros count because they're between the 1 and the 2 that count. And so essentially you're looking for your first non-zero number, boom. That's where the significant digits start, and then they carry from there. And then, you know, we've got sandwich zeros, we've got leading zeros. You'll never guess what comes next. We call them trailing zeros, but what we have here is a number with 4 significant figures. 1, 2, 3, 4. Again, rule number 3 says these don't count, so we throw them out. So it's just the 4. Alright, now rule number 4 is tricky. It's kind of an if-then statement. So, trailing zeros. So, just to be clear, sandwich zeros are in the middle, leading zeros are at the front, trailing zeros, guess where they're going to be? We've got the middle and the front taken care of. We're going to start stacking them on the end of the number. So, trailing zeros are only significant if, so this is conditional, if the decimal point is present. I've got just enough room here for an example on this page. So I'm going to move it up a little bit. So, for example, if I have 0.01002000, I hope you caught that that was going to be my example, by the way. But we're going to do another one. We're going to have 100200. 2 different examples here. Alright. So I look at this and I go, okay, that 1 counts, that 2 counts. So we'll start on the left, then we'll look at the right. And I know these sandwich zeros count because of rule number 1. I know that this isn't going to count, that isn't going to count. Rule number 3, never trust those leading zeros. The decimal point being present has nothing to do with leading zeros. They just never count. again, they're gonna take you for everything you own if you trust them. Give them an inch, and they're gonna take a checking account. All right. So, what about these zeros on the end? Well, these are trailing zeros, and see how we have a decimal point present? So that's gonna count, and that's gonna count. And so I'm gonna have 1, 2, 3, 4, 5, 6 significant figures. All right. Now let's compare that to the number on the right here. Rule number 1 says 1 and 2 count. Rule number 2, sandwich zeros count. Rule number 3, there's no leading zero, so it doesn't come into play. Rule number 4, trailing zeros count if the decimal point is present. There is no decimal point written in this number. They don't count. Now, if the decimal point is anywhere, it could be at the front, it could be at the end, it could be just right there. It could just be after the last zero. You don't have to write anything after decimal point. If it was there, they would count. But there is no decimal point present, so they don't count. That means I have 4 significant figures. 1, 2, 3, 4. So, I think rule 1 and 2 are pretty straightforward. I don't think students really struggle with them. And rule number 3 is straightforward, but 4 is tricky, and 3 and 4 get kind of entangled in people's minds. Get out of here. I'm done with you. Alright, so let's kind of just put this to practice here. Make sure it makes sense. Alright? So, if I have something like the numbers, let's see, 5,203.0, and then I have, 100, and I have 0.0001, and let's do one more, right? I got tons of paper space here, might as well make use of it. And then I have, what else can I do? Is there really anything tricky I can do at this point? Let's do that. 0.00010000. Okay. So, how many significant digits are in each of these numbers? That's what we're going to ask. Alright. So, rule number 1 says these count. Rule number 2 says this counts. Rule number 3, there's no leading zero, so don't worry about it. And we've got a decimal point, so rule number 4 says that zero counts. So we got 1, 2, 3, 4, 5. And you always want to take a second and make sure you count these up right. There's nothing more earth-shattering, to your self-esteem than when you just fail to count to 5 correctly or something. And it happens. It happens to the best and worst of us. I've certainly done it in front of an entire class on a board at some point, I'm sure. If there's ever a mistake to be made, I have made it in front of an audience. So, if you're home doing this and you just miscount, it's cool. Just, learn from the mistake. Just be careful. Alright, so let's look at the second number here. 1 is not a 0, so that's going to count. I know, earth-breaking. We are redefining, math theory here. 1 is not the same as 0. You can literally take a class, and that's like the only thing they'll give you. Like everything else you got to prove. But they're like, yeah, 1 is not the same as 0. You don't have to prove that. There's like these things called numbers, and they mean stuff. Okay, every math operation. Show me 2 plus 2 equals 4, and it takes a page. I never took that class, and I'm happy about that. Alright, so we've got some trailing zeros here, and no decimal point. Well, then they don't count. So we only have one significant figure. If I had a decimal point there, for example, if I go 100, just point, it feels weird, I know, but you can do this, then you get 3 significant figures. Alright, so 1, because there's no decimal point, that little dot, bam, suddenly these become measured values. So this is the only one we know for sure we measured. These might have just been rounded or something. But now we know we can estimate to the nearest 1. That's where this comes in. We can estimate the nearest tenth here. We had equipment that could do that. Here, maybe you walked it out and just estimated, oh, it's 100 feet or something. Okay, so next we have 0.0001. Now this is where you can fall into a little bit of a pitfall. You're like, oh, there's a decimal point, so these zeros are going to count. Or maybe the ones after the decimal point. No, that's a leading zero. That's a leading zero. Leading zero. Leading zero. Do not trust them. That 1 counts. That's our first significant digit going left to right. That's where significance begins. There's nothing after it. 1 significant digit in this number. Now, what we have here is the exact same value, just written with what we call a higher level of precision. So again, these leading zeros don't count. The 1 counts. There's a decimal, so all these zeros at the end count because the decimal point is right there. And so we have 1, 2, 3, 4, 5. 5 significant figures. That's beautiful right there. No Sharpie eraser, so just bear with me. So, that is how we use these rules. Now you can get a little bit of ambiguity. We'll talk about that in a second. And scientific notation is how we address that. So I'll have one more piece of paper on this video, and then we'll jump into the rules for addition, subtraction, multiplication, and division. So, this is what we call a higher precision number. We're going to talk about this more with addition, subtraction. But just a heads up, like this is precise to this decimal point, but this one is precise to 1, 2, 3, 4 more decimal places. So this would be a more expensive piece of equipment we're doing with this. Either that or it wasn't used very carefully here. Someone wasted literally dollar value of decimal places. Okay, so we're going to talk about scientific notation. So what this is another way to write numbers. So if we have something like 0.001, well, I can write this in scientific notation. So I'm just going to do this. I don't even need an arrow, actually. This is straight up equal. This is 1 times 10 to the 1, 2, 3, 4, negative 4. So how did I do that? You know, maybe you've seen this in a math class before. But if I move to the right, that's 1, 2, 3, 4. So there's a negative 1, negative 2, negative 3, negative 4. And that 1 goes right there. Now if I have something like the number 0, 0, 0, 1, 0, 0, 0, I don't know, maybe I only had 3. I think I had 4 before. Well, what we do is we write all of our significant digits here and we put our first number in the ones place. That's what I did. That's why I have to multiply by this 10 to the negative 4. And so this is still going to be something times 10 to the negative 4, because in order to get my first significant digit, I need to go 1, 2, 3, 4, and that's negative 1, negative 2, negative 3, negative 4. If you go to the left, you're multiplying by positive powers of 10. So, I write all of my significant digits, so I get 1 and then a decimal point, because this 1 is going to go in the ones place, and I'm going to have 1, 2, 3, 4 zeros after it because they are all significant. So the cool thing about scientific notation is every decimal point, every digit you see in this first number, these are all significant. They're all significant digits. Now here's the cool thing. You can have significant figure, significant digit ambiguity. So maybe you have a number like, you measured out to the nearest 10 and you get 100. And so what that means, if you measure it to the nearest 10, is there's 2 significant figures in this number. But how do you write it that way? Like, how do you tell people? So there's an ambiguity here. Because if I go, oh, it's 100, and we'll say this is like meters or something like that. So we'll bring some units into it. We'll stop messing around with just boring numbers. Well, that's 1. And you go, oh, okay, well, what if I write the decimal point, right? It's 100 point dot, you know, nothing after it, meters. Well, now I have 3. I think we're all comfortable with the idea that that's not a 2, and that's not a 2. So what do? I write in scientific notation. So I've got 100 meters, and that is going to be something times 10 to the, in this case we're going to the left, so it's going to be positive 2. And the 1 in the first zero count, guess what that is? 2 significant figures. So that is how we can control scientific notation and use it to get rid of this problem. Like if we measure, because sometimes you just have a 0 that counts followed by zeros that don't. And how do we address that? Right there. Or you just measure, and pass the right hand side of the decimal place, but that's not always in the cards, right? Move that up a little bit. So that's what we're looking at. Alright, so now we're going to get into, whoa, this video got long. We're going to get into addition and subtraction and the rules for that, and then we're going to get into multiplication and division and how we handle that. So now hopefully you're comfortable with how to figure out how many significant digits are in a number, but now we're going to talk about, well, what about if I do some math? How many do I get to keep at the end? So we don't just measure values. We often use those values in calculations. And so we have to account for our error not just at the beginning, but through an entire series of calculations to get to some other value. This happens all the time in things like, in every field of science. Happens in construction, engineering, on and on. We have to keep accounting for that error. We don't want to over-report. If we measure 2 significant digits, if we even measure to the nearest 10, we don't want to make it seem like we measured to the nearest 10 millionth later by over-reporting. So, your calculator is just going to do the math. And the math hasn't changed. That's the first thing I want to say about this. The math hasn't changed. All that's changed is how we might need to report our answer. Maybe we have to round or something like that. So we'll get there. So now we're going to talk about feeding this into calculations. That's what we're going to do next.